Okay? Okay. Well, why don't we go ahead and get started this afternoon, and more people will trickle in as they can. Let me introduce myself. My name is Matt Domo, and I am, give you a little brief about myself. I'm the Group Program Manager of the group in Microsoft which produces our data access technology, so ADO, ODBC, OLEDB, et cetera, and our MS XML parser, so all of the ways that you can take XML data and read it and transcribe with it, et cetera, and also the work that we're doing with XML in SQL Server in the next release, of which will be detailed in some very granular detail in a presentation on Thursday. What we're going to, I had to have the obligatory slide for what we're doing for every slide presentation here, which is just basically to talk about the Windows DNA next generation web application platform. Try to say that 3 times real fast. The bottom line here is that we're working to deliver the platform that will enable you to build the next generation web application. And this actually sets the tone for a lot of what we're going to discuss in today's session concerning what we're doing with XML and Microsoft. XML is going to be a pervasive cog in the architecture of building the next generation web application and applications that will be integrated together for business-to-business purposes. So the key factor here is that XML is going to be one of the big things that drives innovation moving forward. So the agenda for today's session, the purpose of the session today is to say, not to come and tell you, this is XML, this is what XML is about, this is how you read through an XML document and form that. You can all do that on your own, read some documents, get some books, work with the W3C, the W3C specifications, et cetera. The purpose of today's session is what XML is going to provide for you in the future as you embark on building your next generation web applications and as you start focusing more on business-to-business operations. We're going to talk at a 50,000 foot level, why XML is important, why it makes sense for you to make it the way you communicate in a data format on a daily basis. We'll also talk about what we've heard from customers, what we heard about the World Wide Web, what works, what doesn't work, what's needed to take it to the next step. Then we'll talk about some architecture. So we'll talk about the first several steps in how web applications and applications in general were built, and we'll talk about how that's evolving into the next generation architecture that we're going to be depending on in Microsoft for you to build the next generation of web applications. We'll also dive into a bit of strategy. Over pervasive throughout the conversation, we'll talk about how XML is important, how we're going to be integrating it into our products, how you're going to be able to take advantage of the architecture we're proposing to build those web applications. And then we'll talk about our policy and what we feel is important in XML and what we're going to drive as a company. And then we'll talk about the required steps for you to take this information and go forth with it and start doing things. So at a 50,000 foot, I can't say that over and over. At the 50,000 foot level, bottom line, XML is going to be the format in which you communicate for data. So XML will be the data format for how data is exchanged between your client and your server, between your server and your middle tier, between your different applications. We're betting on it. It's earlier, in about a year ago, it wasn't inherently clear whether XML would step up and take that level of control and how things will integrate, and that's definitely not the case anymore. We're definitely sure that XML is going to be the format in which we all communicate for the foreseeable future. So why is XML important? I mean, what do you get from XML? The thing about XML is it's just simple. I mean, you don't have any inherent difficulties in how you describe the data. It's self-describing. I get an XML document that describes a customer, an order, and details, and I can take that XML document and I can send it to anyone I want. And given the schema or a contract that allows me to describe what is made in that document, I can easily read through it and process the data. The key factor here is that it's open. There's no implementation-specific details of XML. It's defined on an open, evolving standard in the W3C. We heavily participate in the W3C standards. We're represented on many of the standards committees, and we're committed to driving open innovation in XML. Another key attribute, because it's open, because it's going to be that data format, the key factor here is XML makes data more important than the code that you write to access it. Because it's open, because there's no implementation details, you're not tied to a specific language or platform or architecture to allow you to communicate in this environment. All you need to know how to do is take an XML message or document, read through it, and process the data. The other part about it is XML is going to enable you to build more powerful web applications. One of the key beneficiaries of XML and its openness is going to be the business-to-business environment, how businesses communicate with each other. Because everybody has their own systems, has their own level of their different architectures, has their own implementations. The key factor is XML spans all of that. There's nothing specific in an XML message that ties me to the particular platform or implementation details of how I take data, read it, process it, and expose it to you. XML transcends all of that. So XML supports many different data models. It can represent very different data relationships and different communication formats, and that's the power of XML. It's very much like HTML. Given HTML and data, I could produce a web page that could be read and displayed by any HTML-enabled browser. I didn't need to know the implementation details of what was in the web page in order for me to read it. All I had to do was send HTML, and my HTML-enabled browser would allow me to display the data and pictures that I had imposed or implemented inside of my web page. XML is very similar to HTML, only it's for data. XML describes, again, how I can take data and send it to you for you to process it and store or do whatever you need to do within your system. Because of that, XML has to be able to represent data in a variety of different formats or data models. So one data model that will be important is XML is a hierarchy. I have a customer, and the information about my customers to me is specific to the customer, their orders, and the details of their orders. Also, I might have, and we can drill down into different aspects of that. So you can look at the customer as an element. So the customer element is made up of different attributes or describing factors that tell me what exactly makes up a customer. So in that case, I may have a name, an address, a telephone number, an ID, a mobile phone number, when I last spoke to you, etc. We also have the ability to describe orders in the same format. I can describe an order, and an order element is made up of the attributes of order ID, order date, order description, part ID, etc. Then you can go down into the individual components of a particular order. I can describe a bicycle tire, and I know that the bicycle tire is black with a white wall. And I know that bicycle tire has X dimensions. Its diameter is of that bicycle tire, I can tell. And I can describe other data in there that's not as important to me. So there are other data that I may not care about, but with XML, I can describe a different format, and we'll talk about it later in terms of contracts and namespaces that allow me to take any XML and read it and take the data that I need out of it and process it. What we expose, and the reason I have the DOM on the slide today, is the object model for you to do hierarchical access of XML today in our parser is the DOM. That's what we've exposed in the MS XML parser since we've shipped it. as you want to take, as you take that XML hierarchy, you may want to change its format for how you want to process it, or how you want to store it within your database, or how you may want to take that XML and transform it into HTML for display on a browser. That's where the XSLT, or the Extensible Style Sheet language transformation capabilities of XSLT comes in. I can take an XML formatted message, transform it into a different shape or even a different format like HTML, and use it internally for my own purposes. We can also model XML as a row set. This is where I get a packet of data or a data exchange, and it's well understood what's contained in that data, what's contained in the data, how I navigate through that data, and what is important in that data. And this is very, for example, this might be what is described as like an Excel spreadsheet. I have an Excel spreadsheet that describes what stock information that I'm tracking in my particular account. That information is consistent across every different type of stock that I have contained in my portfolio. For example, in my portfolio, I might have Microsoft shares. And inside my portfolio, I know that I have Microsoft. I can track what price I purchased it at, what date I purchased it in, and any other describing details that I have, notations I want to keep about my Microsoft stock. That will be consistent across every other stock that I have in my portfolio. So very much maps to a strict regimen of how the data is structured and described, very much like a row set in a database. I might create a stocks table in my particular database, and that stocks table has different columns that describe what I want to maintain about a particular stock. I need to know its ticker symbol. I need to know the date. I need to know the price that I purchased it in. And I need to have those special remarks that I want to keep. This is very much like what a row set is in a database. I take my XML element stock ticker and its corresponding attributes mapped to the particular columns in my database row set. So you can see how the correlation goes there. More complex data comes up as well. So I have data with a schema. I can describe, so for in the example, what I showed you about a row set, that's superstructured. All of my data is described exactly the same across every instance. Every stock ticker information that I want to process has the exact same format and contains the exact same data across instances. But as you know, all data doesn't follow that particular same format. So for example, I may have a description of a book up on a website. You log into Amazon.com and you go find a book called the XML Companion. And then you start reading through what makes up that book. I find out the title, the author, the ISBN number, the price. And then you'll notice at the bottom of that web page, I have reader's remarks. That's where folks who have already bought the book can go back up into the website and tell you, hey, this book's really cool. You should read this book. Using this book, I was able to learn XML in a night, etc. And various other different comments like that. The key part of that is those comments are unstructured. They're not consistent across every different user that's going to be describing what comes up with that book. So I may describe different parts of the book than what you may describe. But we all need to be able, but the vendor, in this case Amazon.com, needs to be able to track all that information and keep it stored somewhere so that when you log on and you want to search, you can get that information and view it. That's a very complex relationship between those what we call annotations, or that unstructured format of the data which corresponds to these comments, and what makes up the normal strict regimen of the book, its author, its ISBN number, its title, etc. So using XML, you can map and have an open format for describing complex relations, and that's sort of what we've described in the ball diagram we're here, as we describe teachers, students, classes, and as you work in a working group concerning a project. I have teachers, and teachers make assignments, and assignments are completed by students, and the students could be part of a working group. Those working groups are formed by teachers. Students take classes. Those classes are offered by departments and the departments are where the teachers are from. So you can see the different types of complex relationships that are inherent in data, and XML is an excellent way for you to describe those complex relationships in an easy-to-read, non-platform specific format. I can just take XML and read it with anybody's parser on any operating system, be it Windows, be it Windows 2000, be it Unix, be it Apache, what have you. So the common themes that we hear from different vendors as we go along is that usually the data that's moved around is an intermediate representation. So XML is an intermediate representation of how the data was described and stored in their particular environment. So, for example, in the case I implement a customer ordering system, I have my customers, my orders, my details may be in a variety of different tables. But when I send that data to you packaged as XML, that XML is a representation of how it was physically stored in the database. But it's not inherently mapped to how it's physically stored in the database. So I'm hiding or putting another level of abstraction about the implementation of details of how I'm storing and processing that data within my own system. Because of that, I'm not constrained by the physical formats of how it's stored in the database. I can take data and map it in any kind of relationship that I want while hiding the implementation details of how it's stored in the database. And the other key factor here is I'm not tied to a particular programming language or environment because the data is non-platform specific. As long as the programming language that I choose to use has the ability to parse through an XML message, I'm okay. So the key here is that I'm not saying that I need Java to process XML. That's not the case. XML describes data. The power of what you're trying to access here, and the key here, is data. I don't need to have a particular language to do that. I could use Visual Basic, I could use C++, I could use C, or I could use Java. So what's going to happen here is, so now that we know we can take data and describe it into a format that's easily understood by a variety of different platforms, clients, applications, architectures, etc., what's going to make XML powerful moving forward is to have it become a message format, where an XML message describes the level of interaction between how we communicate with each other over the internet via our computers. So we're not tied. It's transient data. So it's data that's a particular snapshot of an instance of interaction, and it doesn't exist in a particular data store. So, example, you and I might be talking over the internet, and I send you a mail message format. That mail message may not be stored in a data store as it's traveling along the internet. All I know is that I have this message, this level of interaction for how we want to communicate with each other, and that message is formatted in XML. So what XML takes data is what that does for you is it takes data and allows it to become a message. And that message is the wire format for how we communicate with each other. All we have to do, and we'll discuss this in greater detail later on in the presentation, is describe the format of how we want to communicate with each other, and then that's all I need to know to interact with you. That way, all I have to know is that a message or how we communicate with each other takes this format, and that's it. I don't need to know that what your implementation details for producing that message is, and you don't need to know my implementation details for how I'm going to take that message, process it, and possibly change it and send it back to you. All we have to agree on is the format of how we're going to communicate with each other. That's the value of what XML is going to drive for you in the future. So what do we hear from customers? We went on an extensive tour this past summer and over the last few months, and we went to talk to 75 of the top .coms out there in the world today. We talked to many different corporations, and we've talked to many people who are consultants and such concerning the World Wide Web and how people are going to build the applications on the web in the future, how people are going to communicate in the business-to-business environment in the future. A couple of the things that that we've learned from the World Wide Web is that web pages are, it taught us a lot about how people are going to communicate in the future. So for example, when I first brought up my web application, all I needed to do was to send you an HTML document or an HTML page, and that's all you needed for me to interact with you. So I would describe the information that I wanted to see to you on your screen. You'd make a request and say, okay, I want to see the information about your office desks that you offer from your office supply company. And as I received that request, you would make an HTTP GET for that. I would respond to you with a coarse-grained interaction consisting of an HTML document that contained data and pictures, etc., and an all-in-once transfer. What we've learned there is that that's platform neutral. All I needed to do was take HTML and have an HTML-enabled browser, and I can easily see the data and pictures, etc., that you wanted me to see concerning the office desks that you offer from your office supply company. The other thing we learned from the net is that interactions are coarse-grained. So I make a request and I get the data all at once or not at all. If I didn't get it the first time, I can hit the refresh button and keep hitting the refresh button until I successfully receive the data that you wanted me to display on my browser. The other thing that we've learned from the net is that it works on totally unreliable implementations of networks, etc. So with high latency, it works on somebody who's got a 24/4 modem or a 24/4 connection. It's with high latency that takes a long time for the data to get to you. The net provides mechanisms for you to exchange data in that type of format. We also learned that there's caching at all levels of the system, but little application state is needed in the particular client. So I need little information to interact with the client. All I need on the client is to store URL to my office supply company and a cookie on my particular system that describes my security permissions, my interests in what's stored on your site, etc. The other thing that we learned from the net is that protocols are designed for routing of messages. So HTTP itself is designed for the routing of messages that is independent to the architecture that I have employed in my system. All I need to do to communicate with you is to understand the specific implementation deals of the HTTP protocol itself, and I can take those messages and send them and receive them with you. And the ability of these protocols is that they can degrade on less capable systems. If I've got a very high-powered connection to the net, well, hey, I just get my data faster. If I have a less powerful connection to the net, like in the case of a 24/4 modem, I still get the data. It just takes a little longer to get there. One thing we hear, so the new job for the new job for computers moving forward is the level of communication and interaction between different computers and different systems. So computers today and the net today is great for UI design. So I can take computers today are great for doing different computations. I can run an Excel spreadsheet, look at my Microsoft shares, multiply those number of shares by the price today, and I can know exactly what my assets are. I also have the ability to render different UIs, different displays, different views of a particular data. Computers are excellent today at rendering data and putting it in a very easy to understand format. They're also very good at storing personal information. That's great for me for my personal productivity. I can create a Word document, and that describes what I'm going to do on a particular project, or I can describe my own employee evaluation for my review with my manager. And computers today are great for allowing me to store that data, interact with that data, massage that data in a particular application. So the new frontier, while that's great today, the new frontier is to expand the reach of the computer over the internet and so we can make each computer capable to communicate with various different people who are relying on various different systems and architectures to interact with each other over the web. I don't need to know that on my side I have a Windows NT computer and you have a Unix computer, and that's our different server implementations that provide our network services to communicate with each other. We need to be able to expand the reach of the personal computer today and allow it to interact with those various different systems moving forward. So what does that mean? Well, the web today is very much like a big glorified slide projector. I take an HTML message or an HTML document or page that's packed with text and pictures, etc., and I throw it up to you and project it on your screen via your HTML browser. It does not yet do very well at taking data and exchanging data with different people, different clients, different machines, different applications. So and the key here is being able to take the data that does come. While it does move some data, it's very difficult to take the data as it exists, retain how it's formatted, etc., and process it efficiently such that I can take data that you've exposed in your particular system format and easily read it and process it and store it as I need to do in the system that I have implemented. So the bottom line here is the new job of computers is to interact on data, not on particular formats. Opening us, and this is going to open up how we build applications moving forward to a variety of different avenues. The big thing will be business-to-business interaction. As I store my data about how I store information about you, my customers, what you purchase, how you purchased it, where your bank information, etc. I can store that and keep that in my system. And you will be able to interact with me on your own business. So as we interact together, say we embark on a venture together where I produce bicycles and yet you produce the bicycle tires. For business-to-business interaction, we could produce a website that allows us for the people on the web to get bicycles, but the individual parts that make up those bicycles will be described and maintained by different organizations, and we can roll that up in our own application and sell that up on the web. So it becomes the data and how the data is formatted and how that data can be read and shared amongst different computers and systems. And that's where XML comes in, because XML will be that data format moving forward. So, as I said, data is sent by computers today, but it's not in a very webby format in how they interact. The details of data is very vendor specific. So, for example, when I interact with SQL Server and I get data, if I didn't have a Microsoft client, the data that's sent out from SQL Server is sent over the tabular data stream. Every data store has their own different format for how you make a request for that data and how that data is sent back and processed to you. So to get that data and read it and process it, I need to know the vendor-specific implementation details to crack that data format and read it and process it. So as I have those private formats, I also use private protocols and search capabilities that are specifically tied to my particular implementation. The value here moving forward is to keep it open, hide implementation details, make sure that what I do and everything you need to get from me is described in the data message format that we'll be sending back and forth. So addressing this requires two changes in the architecture moving forward. Number one, we need to create a messaging-based architecture for how we'll be communicating moving forward. So we need to describe the level of interaction for how we interact as a message. I make a message that's a request for data. Then you take that message, process it, and reply to me in a specific format that we have agreed to, and that's called a contract. We'll describe it later. In a message format. And the key for that message format is a universal language that describes what makes up that message format, what's contained in it, what its shape is, what has to be in there, the formats. That universal language is XML. So, are we loosely coupled today? And the answer is not really. Data is packaged and processed on each side of a business interaction today by the specific implementation details of the system I've deployed. So web and how you interact with my business or my website is specifically tied to the methods and properties that I have exposed on my architecture within my application or my web server. So you have to know those. So I'm website A, and I expose the customer, the orders, and the details methods, and each one of those has properties associated with it. In order for you to interact with my website, you have to know the implementation-specific details of those objects, their methods, and their particular properties. So right now, it's very hard for different businesses and different sites to communicate with each other. And it's also not easy for me, being on the outside, not knowing your implementation, how to discover what you do make available to me. What methods and properties do you expose into my system and my data? And given those methods and properties, how do I utilize them within my own application? So let's go into a bit of detail about how web apps have evolved over time, and this will provide us the framework for how XML will take and evolve the next generation of websites moving forward. These slides may or may not be in your printout, I'm not sure. So a brief revisionist history, so to speak, and the history of the web start out, like I said earlier. I made an HTTP GET request for you, the office supply house, to tell me what describes desk 147. In response to that HTTP GET request, you sent me back a packaged payload that contained an HTML page containing the graphic, the picture of desk 147, and the particular attributes of that desk. Its height, its width, its length, its color, what made up of it is. It got have a metal base and a wood top, etc. And that started out as a kind of a file sharing mechanism for how we communicated. You shared the file that described what that desk was made of. Then things started getting interesting. People didn't want to create a specific file for everything they wanted to describe and expose on the data, of their data. So they started creating CGI scripts that created dynamic pages where I could create a raw format that describes everything I wanted to display, and then I would use queries to go query the database and produce the dynamic content that would be exposed in my web page, and you would send up to your browser. So that's what the second generation was. I would create my ASP page, and in my ASP page, I would embed HTML, and in certain sections of my HTML, I would embed specific vendor implementation details for querying the database that I have stored that stores all the dynamic content that I want to publish. So it would describe all of the office equipment that I had in my website that I wanted you to see. I would create a generic web page, and in my ASP page, I would go query and produce data dynamically that I would expose in HTML and send to you on the browser. So this meant that developers had to start getting clever for how they created their pages and embedding the different specific CGI scripts to go get the data that I would dynamically publish to you upon request. Then websites started evolving. So if I wanted to talk to another website, I would have to go out and interact with their particular their website. So say, for example, I'm selling sporting goods. This is exactly what my father does today. My father is a sporting goods distributor in the Midwest, and he has his own website. And he has different things to describe some of the sporting goods he sells. He sells Rawlings gloves and Rawlings baseballs, etc. If you wanted to go find out more information about those specific things, my dad surfaces you a link to the Rawlings website, and you can go interact with Rawlings to find out the specific things that describe what that baseball glove is and what that baseball is, and you understand that. But if he didn't want to do that, and say their content changed all the time, what you would do, and as people started integrating this and they wanted to surface other different web applications together, they began starting to connect to the other websites' web pages and screen scraping or walking through the HTML that was sent to them to extract the data that they needed for you to interact with them. So how does that come into play? Like eBay, this is a perfect example. eBay, the auction site, would surface different websites and allow you, or different websites would want to interact with eBay for you to get information from them. And so for example, I wanted to find the cheapest price of a Rawlings baseball glove on the web. So people started getting smart, and as they wanted to surface what the cheapest price is, they'd go connect to your website, grab your HTML, walk through it, grab the price information, send it back and say, well, hey, Adler Sporting Goods in Cleveland, Ohio sells a Rawlings glove A for $19.95. And that caused problems because the guys that were able to go out and do that could go and get your price and be able to beat you, and that would hurt you long term. So how did the eBays of the world stop that? The one way to break that is to go ahead and change the HTML frequently that I surface on my website, such that you can't just connect to it and grab it and walk through it and easily be able to find the information. All you had to do is change the shape of the HTML, and you had problems because you wouldn't be able to interact with it. And so this means that I had to constantly evolve my CGI scripts and the URL syntax that I exposed. So the changes happened from day to day to day, and they were implementation-specific changes. So it became very difficult for you to interact, especially in the non-predatory case. So I want to interact with you, but if you changed how you stored the data in your database, or even you changed your back-end system, that means that I would have to go and change how we would interact with each other and exchange data. So what makes this better is if your architect, so what would make this better and how we need to evolve how we communicate moving forward is our architects get together and agree on an architecture and a contract format for how we're going to describe and how we're going to describe how we're going to communicate moving forward. And so we'll agree on a contract that says my data comes in the following format, and you request it in this format, and I'll process it and I'll send it back to you in another format. And as we add more and more people who want to communicate in that format, the value coming forward will be to produce a thing called a web service. So what the web service does is it can take data that's received from many different data formats and different people. So I can have a web service called Sporting Goods that I surface on the web. And my web service goes out and connects to all the different sporting goods companies and gets all the information available on the web at that moment concerning all sporting goods. And then as you build your applications and as you begin to interact with other businesses and other websites, you interact with that particular web service. And that web service gives you the data that you need to display or interact within your business. So what happens here in that case is that you need to be able to describe these services generically. The web service needs to be able to connect to all these different sporting goods vendors without knowing their implementation-specific details and gather the data that it needs to surface to you because you're going to interact with that web service. So the value of how that one of the key factors here will be the message format for how the web service, how you make a request to the web service, and the web service goes and requests data format from the different stores that are available out on the net. As I described, as you can see I'm building up to, the format of that data moving forward is going to be XML because it can simply describe any different kind of data relationship or format that it needs to. And as I said, it's open and there's nothing specific tied to it. So in this architecture where we start describing web services and how they're going to be interacting with different businesses and different data stores, etc., it needs to have a ways for communicating. So we need a way to keep the system up, keep it robust, and keep it open and extensible. such that if on my end of the communication channel, if I change something, you don't have to go ahead, you don't have to know that and make a corresponding change on your end of the interaction. Because it's open and extensible, and we've agreed to a particular format for how we communicate, we can make changes, implementation changes, independent of each other, provided that our level of interaction always is based on that contract or format for how we're going to communicate with each other. So where this is going to be the case, and this is where you start seeing today all the different schema initiatives coming up, is how we build these XML-based messages and the different formats that are going to take, that they're going to be formatted in. So for example, I'll have a sporting goods format, and it says all sporting good formats are described with this XML schema. And I will come up with another XML schema for describing food ingredients for different businesses that are going to be doing B2B operations for producing food in a mass production environment. We agree that all the different ingredients for a particular recipe take this XML schema, and this XML schema describes the exact format for how the data will be packaged and described, such that we can always know that no matter how we interact, as long as my pie crust is described this way, I can get it from anyone, anywhere. So the key here is that so as you can tell, in early systems and how they communicated, if either one of us, even if we agreed on a format, changed the implementation such that that data didn't agree to that format, I would have to make a corresponding change on my side to keep the level of interaction moving forward. With message contracts moving forward, we need to agree on protocols that are independent of each other and just have those protocols tunnel messages back and forth. The key factor of those messages will be a message that's described in a particular format in XML. So the next generation website, or the next generation web communication, is going to have three basic layers associated with it. The first is going to be the messages themselves. So you're going to take BizTalk, and you're going to connect to biztalk.org, and you're going to take what Microsoft has produced as the largest schema formats available, the largest number of schema formats spanning industries available. And you'll agree to that particular format, so it's such that, so in the case of sporting goods, all sporting goods vendors are going to produce messages that say, okay, when I request information from you about your footballs, the request of that information is going to take the following XML schema, and I'm going to have to describe the sporting good tag, and that sporting good tag is going to have a description tag that describes, and the description tag is going to contain information about what that particular sporting good element is, in this case a football, etc. So I'll have these messages flowing to and from all across the internet between different applications, different services, different browsers, etc. And these message formats will be flowing to and from different named services. So for example, I will produce a service called Footballs, and you will interact and go and search for data on the web, and you'll connect to my football service. And my football service, because you know how to interact with me, we have a contract together. You understand that I understand requests for data in a specific XML format where I have a header, and that header describes that I'm making a request for data. So it has a request tag. And in that request tag, I also have a synchronization tag that says this is my first request for the data. And then I have embedded in that different message the physical request or method for request for that data. All we need to know is that my web services says the message that requests data takes this format. I'm going to process it independently, and you don't need to care or know about that. And when I send you the data about the footballs that I can describe in my web service, that football is always going to be described in this XML schema and this XML format, so that you can always know how to read and gather information about the particular footballs or sporting goods that I make available for you. So I have those XML messages, And then those XML messages are going to flow between all the different applications or services that are being surfaced up on the internet. And then we need a set of architectural principles that are going to describe how to keep that message format and system up, robust, open, and extensible. So as long as we can add and change everything we want on our different sides of the interaction, but as long as the message format that we're communicating with never changes. So let's step up. So we know we've got these messages. We're going to have this big message bus. And when we want to communicate with each other, I'm going to log into my message bus, grab the XML-based messages that I'm interested in, process them, and do whatever I want. And then send and log back in and publish XML messages that correspond for what I want to surface to you. So let's pop up a level of interaction, a level of abstraction. So the things that tie these messages in this message bus together is the service. As I said, the service, this name resource, is going to make available to you via URL the message formats that you want to request. So you'll know that I have HTTP football.com, and on football.com I'll have methods for making a request for data, and methods for navigating that data, and methods for taking data and persisting it. So I have those methods so that I can receive a message. Football.com service can receive a message, process the message, and then reply to that message. So the web services themselves in this environment are going to be the active components that you interact with on the web. And the level of interaction are going to be these XML-based contracts which describe how the resources that are available, how you can manipulate those resources, and how you'll be able to navigate the data that's responded, that I send back to you as in response to your requests. So here's a couple of examples of some different web services that you might have available here. I mean, the possibilities are endless. The key here is that the web services themselves must be open and extensible. So as the web services change, and how they take and receive messages is changed, and how they processes those messages and send it back is changed, they have to be able to change independently of the format in which they do that interaction. So they agree to a contract that says, as I've described, and I can change everything I want in my web service and tie different methods together and what have you, but that doesn't affect how we communicate because we've agreed to a particular message format moving forward. So features and different data can be combined or disengaged independently of the message format in my system. This is exactly some of the key factors of what's provided by XML. So, for example, I have an XML format that describes how I'm going to keep my footballs in my particular organization. I might have a football tag in my XML message, and that football tag has different sub-elements in it that describes the length, the color, whether it has white lines on it, what the material is that's used in that string. Well, another business out there on the web, they might have another XML document or format, and they describe the data in a similar format. So they describe that their footballs have a football tag, etc. So that's one great thing about XML, because I can resolve conflicts by using a namespace. In my interaction, I can create an XML namespace, and then it has a set of prefixes associated with it that says that the mat football has this prefix. So I can say that a football, I know that this football is produced by Matt because it has the Matt prefix in it. And that's different than the football that Rob has, because Rob's football tags have the Rob prefix in it, and they have a special different format. And this allows me to resolve conflicts in how the data is packaged, how the data is formatted, and how the data is sent. As I said, XML is very open. There's nothing specific to it. XML can describe how I want to package that data and send it back and forth. So XML has all the characteristics that you need today to make data available on these web services and how you can search the data. Because as data comes up along, I'm going to be storing it someplace. You know, I have this web service, and it's gathering information about all these different websites and different applications and businesses, et cetera, that are available on the web. And I need to store it someplace and make it available for you to search it. And so the messages that are sent, so the data stores are going to play a couple key roles in the message service moving forward. First off, they need to have point-to-point communication. So I need to be able to make a request on this side and have a response for that request on the other side. You also need to have multiple different views of the data available to you so that I can assign permissions, etc. So imagine I'm a web service, again, that describes footballs or describes sporting goods. I have to have different views available to you on the different service that describes your level of authority and permissions for what I make available in my web service. So I have an XML view that describes that you, the normal user, can view sporting goods in this format using these methods. If I'm an administrator, like I'm a supplier of footballs, then I need to have different capabilities because I'm going to be making different levels of interactions with the web service than somebody who's just querying it to follow information. I need to tell the web service, hey, I'm publishing new footballs brand X, and here they are, and this is how it describes. So I have these XML views that hide the abstraction of the data model of how I'm storing it internal to my organization. And then all I have to do is provide to you those XML views, and these XML views can be queried in a standard format such that I don't need to know the implementation details of that. I just need to know the particular XML view and the XPath query or the XML query language that's deployed, and I can search through that XML view to get the data. It also allows me to filter particular messages. So I'm going to be publishing all this data about the different sporting goods that I have, but you may not care about all that data. All you care about is that what the element is, that it's a football, that it has this price, and that it's available at this date. But I might be publishing a lot more data than that. I might be publishing that the data that the footballs have this color, I got it from this vendor, and it's in this location. You don't care about that. So you just need to have a way to take the XML message I'm going to be sending back with you and navigate through it to get the data that you care about in your particular level of interaction. So data stores need to be able to provide these different views for how they're storing the different data and give you efficient querying interfaces to navigate through those views. So how are loosely coupled databases going to come into effect? So again, they're going to provide the data. So I'm going to break up a customer. You don't need to know that my customer reports how they're stored, that I have customers stored in a customers and orders and a details table. All you know is that you have a customer's view over my particular data store, and then I give you a query interface like XPath that describes how I'm going to navigate through that XML view to get the data I want. In SQL Server 2000, we're going to provide that capability with you. It's called what we call the mapping or annotated schema. And a mapping schema is going to provide to you an XML-based view over the data that you can navigate with XPath and query through that XML view such that I don't need to know the specifics of a username and password and the Transact SQL language to get the data out. All I need to know is that I have an XML-based schema that describes how I'm mapping XML data to object data in the database, and I provide to you an XML or open standard way to navigate through that XML view and get the data. And Rich Roman will be talking about that later on in the conference when we talk about the XML-based capabilities in SQL Server. And so basically, you need to provide these views, need to be able to find a very open, need to be able to produce a very open and extensible format for how you can look at those views and query and get what you want out of from that data and those views. and you need to have an open way to discover the different views that the different data sources are going to be available. So as I have this web service, and this web service is made up of all these different data stores, I need to have these XML views, and I need to make a system called discovery for how you can connect to my web service, discover what methods that I have to interact with all these different data stores, and the properties of those particular methods. So those properties would describe what data I want based on the XML views that I'm exposing from my service. So let's drill down a bit on that architecture I showed you earlier. So in this particular case, I have an application. So my application is sportinggoods.com, and I'm going to communicate with these different services. So I'm going to take my application logic. So when I ship you something up into the browser, my middle tier is designed such that my sporting goods have my object model that's specific to my system. I take my object model and map those objects and their properties to XML objects in a message format that we agree upon to communicate in. That message format's called a contract. So what we say is we agree on a contract and say requests for data take this format, and responses based on that request take this format. So all I need to do in that case is in my application map my requests for data from my objects into that XML-based contract format and send that to you, the web service, which interacts with the data store. So what the web service will do is says, okay, I'm getting this request, get footballs. And I go then and look at the different XML-based views across the different data stores that my web service knows and can interact with. And using those XML-based views, I can go with a standard format, go and connect and query via XPath or the XML query language, etc., and navigate through those XML views to find footballs, which I will then take and map that XML-specific format back into the format of the contract we agreed to in our response. I hope that makes sense. So basically, we're making a request-response format on a wire format based on XML. So we'll be able to, both sides of the interaction can take their implementation-specific details and abstractions of how they've stored that data, and they can map it to a predefined contract or format that we have agreed upon such that we can interact efficiently and not ever know the specific implementation details on each side of the interaction. So basically, the contracts that I've described describe the set of interactions that you can have with a particular content provider or application. So contract says that if you request data about footballs, you have to have this message format to request that data. And when I respond to that request, that data is going to have the following XML schema, and it's going to be made up of these XML tags. Then what that does is that contract allows us to describe how we're going to talk to each other. Then internally, we would create a mapping that says, I'm going to take my middle tier or my application and map the specific ways of how I store and interact with that data and take that XML-based message. So now I've requested footballs from you, and you say, okay, here's an order for 100 footballs on our contract. Now I need to persist that data in my database. So I take that XML that describes the 100 footballs I just purchased and map it to the application-specific objects that I've defined, which is a purchase order and the details of that purchase order, and then I map that XML into those methods that I exposed internally in my object model and use that as the basis for how I'm going to persist in the database, etc. So the mapping enables me to take my XML messages and map them to how I store data in my system and how I query data in my system. And when that data format is different than what my objects expect, I need a different way to change that format. So I may have additional information, or our agreement is that the purchase order has format made of customers, orders, and details, but the way I've implemented it is that I just need one glorified string that says customer, orders, and details all in one line. So I need to be able to take that XML-based message and transform it into the format that my application's objects need. And I would use something called XSLT to do that. I can take XSLT, run it over the XML-based message, and transform the XML that we've agreed to on our contract to the format that my systems know and expect, and then pass it to those objects for use in my system. You'll do it on both ends of the interaction that way. So going forward, Microsoft as a company, we're going to support open standards based on an open architecture that's easily extensible. So the key here is that unlike earlier mechanisms such as like RMI, the remote method invocation model, that assume intimate knowledge of how I'm going to make requests for data and communicate, XML itself is based on a public format. XML is just public. We're going to communicate in public-based schemas that say, this is how all these messages should be formatted and how we're going to interact. And XML lends itself very easily to produce those different formats that are open. The key here is, as long as we agree to a message format, the messages themselves can evolve. As long as we keep to our specific contract, we can always interact. So the messages themselves can have different information available to them, provided that it always contains the information based on our contract. So these contracts are going to describe exactly what tags in the structure of the XML messages that we're going to make requests and responses from. These are all open, so there's nothing vendor-specific about that. XML is an open standard. There's no implementation details into an XML-based message structure. So we'll use XML messages to describe how we're going to interact, and we support the open format. So as XML evolves, we'll embrace those standards and move those standards into our products, such that as long as XML evolves and keeps open, we'll make our server products and developer products evolve in that open format moving forward. So one key here is something that you may have heard of called SOAP. So SOAP it's called the Simple Object the Simple Object Access Protocol. Sorry, I'm getting a little tired. Thank you. So what SOAP is it's just a small set of tags that describe for me how we're going to express a request for data, and based on that request, how I'm going to respond to that request. So SOAP provides those set of tags that describe the format for requesting data, and it also describes a set of tags for how I'm going to respond to data in that format. So you take SOAP-based messages and combine them with digital signatures that uniquely describe who produced the messages and where they came from, etc. And then SOAP is going to provide you a very secure, simple way for exchanging different data messages over the web. I can always know who made the request because I have that digital signature. And based on that digital signature, I can describe what level of interaction that I make available to you within my particular system. So SOAP is just a platform spec that allows flexible addition of richer and richer messaging capabilities inside of our interaction. So using SOAP, we describe how we want to interact, and we can always change that. So SOAP provides the basis for that contract for how we're going to communicate moving forward. And it describes that I produce a message in this format, have this header. It also describes that I have a guaranteed method of delivery. Because I can make a message to you, like, for example, when I connect in my shopping cart and make a purchase order, you disconnect from the website, and a while later you might get an email that says, okay, here's confirmed receipt of your purchase order. And then after a while, I'll send you back another message and says, okay, got this purchase order, the parts came in, I sent it back to you. Those are timeless connections. I mean, they can happen over the span of seconds, minutes, days, months, weeks, etc. So SOAP describes, those SOAP messages describes how I'm going to make that purchase order request And SOAP also describes guaranteed delivery, that once I've received that request, acknowledges the receipt of that request, that I'm guaranteed to send you back a message that says I've received it and here's the data that corresponds to your particular request. And we can always evolve the format of those messages and the content that's described in those messages using SOAP because it's based on the open XML format. So we're going to encourage the participation. We're heavily involved in the XML standards and the W3C standards on the internet, and we work heavily with IBM and Oracle in the standards process. We've been working with them for years on collaborating on XML schemas. So the XSD, the XML schema definition, the official schema definition coming out of the W3C. We've been working heavily with Oracle and IBM on the definition of schemas and how they're going to describe the data format in XML. And we work closely with the W3C to make sure that we build common standards that are open to every different architecture and system implementation available. Now, given that, how are we going to respond to that? The bottom line is all web, all the time. These standards are constantly evolving. The way we're going to respond to that is via a format called web release. And the first one we did occurred on January 26th of this year. So as we innovate and produce our products, traditionally we make shrink-wrap products that are made off of long release cycles that are packed with lots of features, but they take a longer time to get out there. Well, these standards are constantly evolving, and market demands are coming along so fast that the standards are constantly evolving, and the needs of customers are constantly evolving. So they can't live tied to 2-3-year cycles to get the features they need. The way we're going to respond to that is to do something called web releases. So as we make our production release parser available, we'll add more and more features to it in an unsupported pre-release format up on the web, such that we can respond to market demands and give you the functionality that you need in the parser, put it up on the web. You can constantly connect to our website and grab the latest parser so that you can respond and get what you need out of the parser. And we can continue to innovate both internally to our own products' needs and needs of our customers, and also to keep up with how we track the standards. So we're going to be constantly updating our website with updated parsers and updated tools and updated samples and documents that describe how you're going to take XML and this architecture moving forward and integrate it in your environment. And we're going to produce this on web time all the time. We're going to constantly be updating our website to give you these latest tools and parsers and how-tos and samples. So our policy moving forward is we're going to provide the best tools available for you to build this architecture and how you can interact with that architecture using the Microsoft framework. So we're going to provide to you with Visual Studio 7 and beyond the best way for you to develop these web services that I've described, and also the contracts and the XML messaging that's based on that. So you can take our WinDNA framework moving forward and use our tools to generate what you need to produce those web services and the interaction. And we're going to have XML everywhere. XML is going to be our data format for how you produce documents and messages moving forward. We're going to have, as you know, you may have heard of BizTalk, and BizTalk is just is our guideline, or our proposal for XML-based schemas and the guidelines for across industries and how you're going to describe those interactions moving forward. So like I talked about sporting goods, we'll say that all sporting goods are described in this XML schema format. And then we'll give you a grammar for defining how the messages, like SOAP. So via SOAP, I can take my request for footballs, and that response will be a BizTalk, the BizTalk message coming back that contains information about the particular footballs. You can go and connect to biztalk.org on the net today and find out about this framework, find out about SOAP, and how to publish and find schemas that we're describing in this way. And it's also in a community for you to exchange ideas. We have discussion forums on our sites that say, wouldn't it be, you know, these are great, but we really need you to make these level of changes in your schemas because that's what we need in our interactions. Or, you know, it's really cool that you have these XML schemas. It'd be great if the MS XML parser could generate XML data transformed into those particular schemas, because that's how I'm going to be communicating via my contracts. And the BizTalk server is going to be the server for routing and mapping all these messages across your services internally and externally. So the required steps here that you need to do moving forward is take a schema, and messages in XML must be able to describe, I must produce a schema that describes the XML format that I have in my database. And I need much more, much richer schema language than just DTDs, because I don't have scoping. I can't scope the particular object local to my domain. I also don't have stronger typing. So work is underway to get that, and that's called the XSD, the XML schema definition, that'll be the official W3C schema way for how you describe XML data. In the meantime, it's got a ways to go. You can work today with what we've published in a schema standard we've been shipping for a while called XML data. And you can describe these XML-based messages formats today in XML data, and BizTalk server will be able to route those messages for you throughout the internet. And then, as I described, I get this XML message, and now I need to navigate through it. There is an XML language, query language, going through the W3C, and one of our folks is chairing that committee, is working on that committee for building that XML query language that will allow me to navigate through the XML message. But work is just beginning on this front. It'll be a while before that comes into fruition. So today, you're going to need a way to navigate those XML-based views, like I described, that'll be described in further detail by Rich Roman in SQL Server, and you'll be able to use XPath, which is the pathing semantic in XSL, to navigate through the XML-based view to get the data you need, and use XSLT to transform it and take the mapping and transform it back and forth to the different contracts until the query language evolves. So again, the point-to-point invocation, moving forward, we plan to support SOAP. And all of our products over time will start supporting SOAP for how you take and request data in a specific format. And then we're working on ways for how you discover all those different methods available to you. So on my web service, how do I connect to my web service and discover the different data that's available via that web service? There has to be moving forward, a standard moving forward, but until then, we're going to support an XML-based solution, and as our platform evolves moving forward over the next year, we'll start exposing to you how you can make and discover data in an XML-based format using our platform and our tools. And when the XML, when a standard for discovery does become available, we'll jump right on board and support it and migrate it throughout our tools. So in conclusion, again, XML is going to be the format and data model for information moving forward and for how we're going to communicate. Last year, this was in doubt. We weren't sure that XML would take on this level of need, and now that's no longer the case. We definitely know that XML will be that format, and we're betting on it. So some resources available for you for some further information about XML and architecture and web releases and everything will be on our Developer Center and MSDN, msdn.microsoft.com/XML. Every few weeks, we're putting up more and more new content. We'll be releasing more and more parsers and tools and utilities that will make it easier for you to start building these XML messages into your architecture and framework. You can also learn about BizTalk and the schemas and the BizTalk server, et cetera, on those links, and you can track them with the W3C standards using that link. And that's all I had today. If there's any questions.